Okay, last week we started the linear programming. I explained the concepts, and but the only difference was just that it wasn't recorded. Okay, and we had an illustration, which of course we couldn't complete the question. But what I will do within the next few minutes is to explain the concept again, and then we continue from where we stopped in the illustrations that we were solving on Akanchawa. Then thereafter, we are going to have one more illustration. Then after that, if we still have some minutes or hour, we can move to CVP analysis, cost volume profit analysis. All right. So last time I explained that linear programming is a technique designed principally to allocate limited scarce resources among competing product line in a judicious and efficient manner where there are multiple constraints. Okay. Linear programming is used when there are multiple constraints. And then again, the intention, the objective of the organization is to either maximize contribution or to minimize cost. And we also said that where there are multiple constraints, for example, raw material kilogram may not be sufficient, labor hours may also not be sufficient. So when this happens, the limited scarce resources will need to be allocated among competing product lines in a judicious manner in order to take advantage of market conditions and to maximize contribution towards profits. We said there are 5 key assumptions of linear programming, and all these assumptions, you are likely going to apply them when you want to determine the optimal production plan. The first objective is a single economic objective. Okay, the first assumption is single economic objective, which states that there must be only one objective to be achieved, either to maximize contribution or to minimize cost, but not the two at the same time. And I also mentioned that even though in practice, organization can have multiple objectives to be achieved. A company may want to maximize contribution. The same company may also may want to minimize cost. Not only that, another objective may be to ensure customer or to satisfy customer to ensure customer satisfaction and experience. Another one is to enhance employees' satisfaction. Okay, different objective an organization may want to may achieve in practice. So, but in theory, linear programming is saying that there must be only one objective to be achieved. That is either to maximize contribution or to minimize cost. The second assumption is certainty. Under certainty, we said that the factor of production, okay, all the factors of production, including material kilogram, labor hours, or machine hour, must be known in advance and with certainty. You must know how many kilograms of material is needed, okay, to produce, how many labor hours, how many machine time the company will use for them to be able to produce the final product. So that is what certainty is all about. Okay, all the factor of production, raw material, kilogram, labor hour, machine hour must be known in advance and also with certainty. The number 3 assumption is linearity, which states that relationship between the objective functions and other factors of production must be expressed in linear fashion. And I express it for you that, say for example, you have 5 kilogram, there's 5 kilogram of material. You're also given, say for example, of material, 5 kilogram of material A, okay? say you are given 5 kilograms of material A, 2 hours, sorry, 4 kilograms of material B. Let me write it. Okay, 5 kilograms of material A, 2 kilograms of material B. Okay, of material B. So, and then the total available material kilogram is 100. Therefore, I will say equal to 100 kilogram. So when you express something like this, that is called linearity. So the relationship between the objective functions and the other factor of production must be expressed in linear fashion. Okay? Then number 4 assumption is divisibility, which is premised on the fact that fractional output can be produced. Ruth, please mute. Fractional output can be produced. It's not compulsory that you have to produce everything. An organization can produce 70% of the total required output. %80 of the required output, 99.9% of the required output. It's not compulsory that it must be produced entirely. That is what divisibility is talking about. That is, fractional output can be produced. And the last one is non-negativity constraints, which state that negative output is not permitted and that the least that can be produced is 0. So these are all the 5 assumptions of linear programming. And all these 5 assumptions are what you are going to consider whenever you want to determine optimal production plan. And it's an examinable area. So do your best to just ensure that you memorize all of them. And I ask you, and I give you an assignment that you should go and form a note on the uses of linear programming, limitations of linear programming, and then there's another thing, limitation, okay, and the limitation of linear programming. So those are the 3 things I ask you to form a note on. Of course, you have it in this material, just like put it in your own material, in your own class notes, all right? So that is for that. Then I also talk about the methods. I said there are 2 key methods of determining optimal production plan. One is graphical method. The second one is a simplex method. The simplex method is out of your syllabus. So our focus is on the graphical method. And I said that the graphical method is used when there are only 2 variables, whereas the simplex method is used when you have more than 2 variables, okay? And then I explained to you the procedures involved in determining optimal production plan. When you want to determine optimal product mix using linear programming, there are some key procedures you are expected to carry out. The first one is to formulate linear programming model. And I also give to you 4 different steps that you can undertake whenever you want to formulate linear programming model. The first step is to define the variables, okay? You need to define the variables. After that, then the second step when you are formulating linear programming is to state the objective function, okay? You state the objective function that the company wants to achieve, either to maximize contribution or to minimize cost. Then the third procedure is to state all relevant constraints, okay? This is where you are going to include all those factors of production that are limited in supply. For example, raw material kilogram, labor hour, machine hour, whatever the constraint in the question, it is under the constraints. You are going to list all of them, okay? Then, of course, step 4 is to state the non-negativity constraint, which states that negative output is not permitted. So all these procedures, the only one that is not here is the number 1 I mentioned, which is to define the variables. Because in most cases, examiner, the product may be given to you in words, so you need to convert it to letters. That is why the step 1 is to define the variable. For example, if you are given, like the question we solved last time, we were given toro and kobo. So when we define the variable, we say let t, let total equal to t, let cobol equal to k. So that is what I mean by define the variables. Then step 2 of determining optimal product mix is to bring out the equation. All the equation that you have determined and you have put in under your linear programming formulation. You bring out the equation. Generally, the equation will come under the constraints, okay? So bring out all the equation there. Then you now solve the equation using elimination method. That's step 2. Then step 3, you construct a pivot table, okay? You construct a pivot table. Then step 4, you construct a graph, okay? You construct a graph. Then step 5, I think, yes, step 5. No, step 1 is formulation of linear programming. 2, bring out the equation and solve using elimination method. 3, construct a pivot table. Step 4, construct a graph. Then step 5, of course, in your graph, you are supposed to determine the feasible region, okay? When you are maximizing contribution, your feasible region is internal towards 0, okay? Toward 0.0. Then when you are minimizing cost, your feasible region will be external outward 0, okay? Any point of intersection, okay, any point of intersection towards 0 is a feasible region when you are maximizing. But when you are minimizing, any point of intersection externally, okay, outward 0, those are feasible region. Then after that, you construct your solution table, okay? You construct your solution table. This is where you are going to have your optimal mix, okay? This same table, this solution table is where you are going to make a decision. Then step 6, you determine the optimal production plan. Okay, then step 7, you determine the profit achievable. So these are the procedures you are expected to carry out whenever you want to determine optimal production plan that will maximize the contribution or minimize cost for an organization. Then we also talk about shadow price, okay? We talked about shadow price. I said shadow price, it represents the extra contribution derivable from the additional units of limited scarce resources that have been fully utilized at the optimal level of activity. In this place where you have your decision, okay, that's your solution table. Where you have your decision is where you are going to have the optimal level. That place where you have decided that so much unit of a particular product should be produced, that is your optimal level. So it is at that point that you are going to have the shadow price. And that's why we say shadow price is the extra contribution derivable from the additional units of limited scarce resources that are be fully utilized at the optimal level of activity. It should be noted that only binding constraints, okay? Only binding constraints, we have shadow price, okay? Only binding constraint, we have shadow price. So the binding constraints are the ones at the optimal level of activity. Then I also told you there are 2 methods of determining shadow price. You can either use dual method or you use increase the number of constraints by 1. And I said that whichever of the 2 that you use, that you're going to arrive at the same answer. You're going to arrive at the same answer. But one is faster than the other. At all time, always use the dual method. Dual method is more straightforward. There are 2 stages of increase the number of constraints by 1, but it's good to know, all right? It's good to know, all right? So that's that. And then, of course, we had an illustration on Akanchawa. So, but we could not complete the question. So we are going to complete the question now. Then we'll move to another illustration. So that's what we did last time that was not recorded. Okay? All right then. So before we move back to the question we were solving before, let me know if you have any question so far.
I have a question, sir.
Talk to me.
Thank you. Good evening, sir.
Good evening.
Immediately after the graph, there is a point where you wrote at point T and K, A, B, C, yeah, where we have 60, 30 for T, 0, yeah, 50, 60 for K. Please, I just need how we came about those figures, how we derived those figures.
It's fine. Okay. Let me show you what we did last time. Let me open to the material. Please mute.
Okay, sir.
Stop sharing. Let me know. Can you see my screen, please?
Yes, sir.
Yes,
Okay.
sir.
So this is the question we were solving last time on Akanchawa. So let me go to the graph. So you are talking about all this, right? How we got these numbers?
Yes, sir. Yes, sir.
So to get the number, these are the numbers that are going to use to determine the optimal solution. Now, like I was saying, when you are maximizing, because in this question, the examiner wants us to maximize contribution. So all you need to do is to identify the point of intersection internally towards zero. So T and K intercepted at this point 60. They also intersected at point B here. They intersected at point C. Okay? So those are the 3 points of intersection. So all you need to do is to find value of T and K at point A, find both value of T and K at point B, and also at point C. At this point A, this is point A here, the one I put in a bracket. What is the value of T? T is equal to 60. That's why you are seeing 60 here. K is equal to 0. You trace it down because it's on a straight line. So trace it down. That's why you have that 0 there. At point B, what is the value of K? If you are using the same way we are doing it now, that's where you are going to, the same sheet I'm using on the screen is what you are going to use on the day of your exam. Therefore, there will be no, except examiner give you graph sheet. I don't know if I can still give graph sheets. So, but if you are not, if you are given graph sheet, all you need to do is to trace it to the left and trace it downwardly. But in most cases, you may not be given the graph sheet. So if you are not given graph sheet, that's not a limitation. Just keep it. You leave that point B because you cannot trace it to the left and get the right answer. It will not be okay. So we left this point B. We now move to C. We said that at that point C, what is the value of A? This is point C here. What is the value of A? You trace it to the left. Value of A is 0. Value of B, value of K is equal to 60. That's how we got this number. But for at point B, we now say that to get the value of K and T at point B, we are going to identify the two equations that intercepted at that point B. Then you now solve using simultaneous equation. So at this point B here, there are two equations that intersect. This equation of 60 to 100. That equation of 60 to 100, that's equation 10t plus 6k equal to 600. There's another equation that went up from that C that went up to 180 and 60. The equation of 180 and 60 is 4t plus 12k equal to 720. So we now brought out the two equations. Look at my explanation here. To determine values for T and K at point B, the most important thing to do is to identify equation that intercepted at point B.
I'm okay, sir.
So you now, sure you get it now?
Yes, sir. Thank you.
So you're welcome. So when we identified the point, so there was no space again because we have done working. We now said C below. Well, if you go down there, you will see the value of K and T and K. How we got the value of T and K? Look at it here. So these are the two equations. These are the two equations that are intercepted at that point B. So we now solve it using simultaneous equation. For K is 50, then T is 30. So that's how we got the numbers. I think this is where we stopped last time. This is where we stopped last time. So we are going to continue from here. The next thing we are going to do now that we have determined value for K and T at point A, B, and C, okay? So the next thing we need to do is to construct a solution table, okay? Construct a solution table. Let me see if I should just continue with this, okay? 1 minute. Let me just continue with this. I've already opened a new worksheet, but let me just continue with this. Okay, let's see. So the next thing we need to do now, which is a step, I stop at, without even labeling. Graph is number 5, pivot table number 4, elimination number 2, okay?
Step 7.
This is supposed to be 3. This one's supposed to be 3, not 4. It's supposed to be 3. Okay. This graph is 4. Then step 5 is what we want to do. Step 5 is solution table. We construct a solution table. In this solution table, like I said, this is where you are going to make the decision. So in this solution table, you are going to state your objective function. And the objective function is to maximize contribution. Under this, we have contribution of 100 naira for T plus 115 naira for K. Of course, we are going to have total. Then, at point A, point
Hello,
B,
sir.
yes?
Our step 4 is construct a graph, which we've done that already.
Yes, whereas point step 5 now, which is solution table.
Okay, see part of the step 5.
This is step 5. I've already corrected it. That step 5 is supposed to be step 4. I've corrected it now.
No, I mean, based on the notes given to us, step 5 is construct a graph. Based on the notes.
Step 1 is formulation of Millian programming model. Step 2,
Yes,
bring out the equation using elimination method and solve
yes,
using
sir.
elimination method. Step 3, construct a pivot table. Step 4, construct a graph. Step 5, construct a solution table. Step 6, determine optimal production plan. Step 7, determine the profit derivable. All right?
All right, sir.
So what you are supposed to do here is that the units that you have determined for each of them from your graph, all those step 1, point A, point B, and point C. Okay, so you are going to multiply with 100. So here I would then say 100 multiplied by, at that point A, what is the value of 100? Sorry, what is the value of T at point A? At point A, value of T is 60, value of K is 0. So I'm going to multiply 100 by 60, 115 by 0. So T is 60 plus 115 multiplied by 0. Again, at point B, I will say 100 naira multiplied by the value of T at point B is 30 plus 115 multiplied by the value of K, which is 50, equal to, then at point C, I will multiply 100 naira by, at that point C, I think the value of T is equal to 0 plus 115 multiplied by 60. So I need to Multiply and give me the answer. 115 multiplied by 60 equal to 69. Here is 6,900. What do you have? Here will be 6,000. $115 multiplied by 50 equal plus 3,000.
8,750.
After I've done the three, just remember. So this is the solution table. This is how to construct your solution table. If you are maximizing contribution, you are expected to select the highest number. But if you are minimizing costs, you select the lowest number. So in this case, the highest number here is 8,750. This is the highest number. At point B, that's where you have the highest number. That is the optimal level of activity. But if you are minimizing costs, you select the lowest number. All right. So point B is the maximum, is the optimal level of activity. So at this point, the next thing we need to do is to determine optimal production plan. Step 6, optimal production plan. Okay, so if I like, I can write it in words. Or let me just come here. I will say Akanchawa should produce. Okay, should produce. Let me write that. Akanchawa should produce. This is where you make your decision. So we are going to produce 30 units of Toro and 50 units of Kobo in order to maximize contribution of 8,750 naira per week. Okay, so that's that. Then my optimal production plan, if I like I said, I can put it in the table. Say this is units. Here is products. So Toro, T, then Kobo. Okay, we are producing 30 units of T, 50 units of Kobo. Then finally, step 7, examiner also said we should determine the profit derivable. So now, when you look at the information given to us in these questions, in the question, we are told that the number of employee per week, all those information we are given in the question relates to per week. And the examiner is asking you to determine profits. You have to be very careful. What kind of, is it weekly profits you want to determine or annual profits? Knowing fully well that the fixed production overhead or the fixed overhead given to you is per annum. The 275,000 is per annum. Let me confirm. Is it 275? I think. Let me check again. Fixed overhead. Where is it?
Yes, 275,000.
Yes. So 275,000 is the fixed overhead. We are told it's budgeted as that is 275. So in this case, so if you want to use weekly, let me just demonstrate the two for you. So I will say weekly profit. Okay. So my contribution is per week because our calculation is per week. So contribution is 8,750. Then, of course, I would then say weekly fixed overhead. Weekly fixed overhead. We are given annual fixed overhead of 275,000. So let's say we have 52 weeks in a year. So this will give us 275,000 divided by 52. That's
5288.
5288. 5288. So you find the difference. This will give us 3,004 something minus 8,750. That's 3,462. Okay, so that's the weekly profits. That's that. So if you want to do annual, if you want to determine annual profits, so alternatively, we can say profits. So in this case, of course, you already have your fixed cost to be annual. I'll just determine annual contribution. Annual contribution will then be equal to weekly contribution of 8,750 multiplied by 52 weeks.
455,000.
That's 455,000. Thank you, Kunle. 455. Now let's the annual fixed overhead. Of 275.
That's 180.
So the difference is 180,000. So this is annual profits. So because examiner did not tell you the kind of profits you have to determine, whether it is weekly or annual. So, but whichever one you do, you are good to go. Just know what you are doing. All right. So that's that. So again, in the question, examiner number 2, examiner says you determine the shadow price. So let's quickly determine the shadow price. So number 2 requirements, shadow price. Now, when you want to determine shadow price, there are 3 procedures. The first procedure is to identify the equations that intercepted at the optimal level of activity. Remember, we said that shadow price represents the extra contribution derivable from the additional unit of limited scarce resources that have been fully utilized at the optimal level of activity. We said that shadow price is a binding constraint, and the binding constraint are the resources that have been fully utilized at the optimal level of activity. So where we have made the decision, our decision that is that the company should produce 30 units of T, then 50 units of K. That is our optimal level of activity. I will then go ahead with the first step is to identify the equation that intercepted at that point. You see that the equation that intercepted at that point is at point B. So this point B, let me just put it there. Step 1, identify the equations that intercept at point B. So point B is the optimal level of activity. Okay, let me rewrite this. Let me rewrite this. Since point B is the optimal level of, since point B is the optimal level of activity. No. What I want to do is to give you the procedure, then we follow it through. Okay, let me just repeat what I've done before. Identify the equations that intersect at optimal level of activity. That's the step. Step one. So I can then say since point B above is the optimal level of activity, the equations are, we have equation 10t at that point B. At that point B, the equation is 10t plus 6k equal to 600, 4t plus 12k equal to 720. That's the point B, all right? We have identified it before. So at point B, 10t plus 6k equal to 600, 40 plus 12k equal to 720. Equation 1, equation 2. So those are the two equations that are intercepted at the optimal level of activity. Step 2, when you want to determine your shadow price, is to find the dual of the original problem. Step 2, find the dual or transpose of the original problem. Original problem is the original equation. Okay. This can be done. Let me show you how to do it. This can be done by changing row to columns, by changing row to column or column to row. So when you want to find dual, just change row to column or column to row, the same thing, okay? This is shown as follows. Please, on the day of your exam, just go ahead and solve. Don't go and be writing it the way that I'm writing it now. I'm just trying to explain so that when you are on your own, you will know how we get the numbers. These are the procedure you're supposed to follow. Don't go and be saying, find the dual of the, you can say find the dual of the original problem, but don't go and be saying this can be done by changing row to column. It's a waste of time. If you do it, examiner will not penalize you, but you are just wasting time. So just go ahead, identify the equation, start from here. Just start from here. All those story, forget it. But for the purpose of the class, I have to explain. All right. So we want to find the dual of the original problem. What are the original problem? The problem is 10t. The original problem is 10t plus 6k equal to 600. We also have 40 plus 12k equal to 720. Okay. The contribution of t is 100 plus contribution of k, 115. So this represents the original problem. That's the original problem or original equation. Now, when you want to find the dual, all you need to do is to change row to column. Therefore, the first row, this is the first row, 10t plus 6k equal to 600. I want to change it to column. Therefore, I can then say 10, 6, 600. I've changed the first row to column. The second row, which is 40 plus 12k equal to 720. So I will say 4. Let me close it. I will say 4, 12, then 720. The third row, 100t plus 15k. 100, 15, 115. So this represents the dual. This represents the dual. And then when you are finding the dual, you have to change the letter of the original matrix. The letter of the original matrix is T and K. As you are changing the dual, you also change the number. Everything in the original problem must change. So I can say X and Y. I can say X plus 4Y, 6X plus 12Y, put the naira sign behind the 600. Okay. Excuse me. Why did it gray out? Okay. X plus another naira, 720 of Y. So this represents the dual. This is how to find the dual problem. Equal to, you can see that when now that you are finding the dual, you see that what you have in the row before has turned to column. Okay. Initially, the original problem is maximization of contribution. As you are finding the dual, it will now become minimization of cost. However, now that you have the dual values, all you need to do is to solve the dual. Step 3, solve the dual simultaneously. Step 3, solve the dual problem using simultaneous equation. Okay, so if that is the case, I would then say 10x plus 4y equal to 100. You can see before, our contribution has now turned to capacity. Our contribution before has turned to capacity, and capacity that we have before has turned to costs, has turned to the objective functional. So 4x, 10x plus 4y equal to 100, then 6x plus 12y equal to 115. Okay, so this is equation 1, equation 2. So multiply the first equation by 6. So I will say 6 multiplied by 10x plus 4y equal to 100. Multiply the second equation by the first letter in the first equation. Okay, multiply second equation by the first letter in the first equation. So 10 multiplied by 6x plus 12y equal to 115. So 6 multiplied by 10x will give us 60x plus 6 multiplied by 4, 24y. 6 multiplied by 100, 600. Then 10 multiplied by 6x, 60x plus 10 multiplied by 12, 120, y. Let me write this one. Equal to 10 multiplied by 115. That's 1,150. So this will cancel this. So, oh, that's finished. Let me extend. I never meant to use this table before. I mean, this sheets. I wanted to use something else before. What's wrong with you? Okay. Let me do this way. Let me redo this. I'll do this one again. Just hold on. Let me copy and extend the table. Okay. That's me with you. Many tests. Oh, that's scatter my work. Step at point B. This can be done by why? How do you scatter? It's shown as follows. Okay. Anyway, let me just go ahead. So here I said 6 multiplied by that's 60x. The other one also 60x plus 120 y equal to 1,150. All right. So let's go ahead. So this will cancel this. So we have 120y minus 24y equal to 1150 minus 600. I'll change the workbook once I'm done with this question. So 120 minus 24 will give us 96y. 96y equal to 550. Therefore, y equal to 550 divided by 96. What do you have there? 1150, sorry, 550 divided by 96.
5.73.
That's equal to 573, 5.73. So y equal to 5.73. Okay? I would then say substitute for y in any of the equation. Let's say equation number 1. Whichever one you use is the same thing you will get. All right? Which means that anywhere you see y, you put 5.73. So in the first equation is 10t plus, I think 6.
10x, 10x.
Okay, thank you, Jerry. 10x plus, I think 6y, no, 4y. Plus 4y. Anywhere you see y, you put 5.73. So here will be 5.73 equal to 600. Okay, let me confirm this for y. So I would then say 10x equal to 600 minus 4 multiplied by 5.73.
22.92.
That's 22.92. Therefore, 10x equal to the difference between 600 and 22.9.
577.08.
Hello, sir.
577. Yes, 0.08.
Hello, sir.
Yes,
The equation 1, is it 600 or 100?
It should be 100.
It should be 100, sir.
oh, it's true. Thank you. It's
No
100.
problem.
Thank you. So I'll come here, of course, supposed to be 100. So 100 minus 22. That will be 722 something something.
77.08.
77.08. Thank you. So x will then be 77.08 divided by 10. X equal to 7.71. Therefore, my shadow price will then be equal to x. Of course, your shadow price must be in naira. That's why it is called shadow price. So x is 777 naira 71 kobo. Y equal to 5.73. So this represents the extra contribution that can be derived. You know, y is equal to x is equal to toro, y is equal to kobo. So which means that from 100 naira that we have for toro is now the extra you can derive from this allocation is 5 naira 73 kobo. For kobo is 7 naira 71 kobo. Okay, so this represents the shadow price. This is how to calculate shadow price. So let's have one more illustration that also includes that involve a shadow price. So you'll be able to see, you understand it better in this second illustration. So let me know if you have any question before I stop sharing, then move to another illustration.
Just scroll up a bit. You can see the last workings. Up. Oh.
You say scroll down,
Okay,
not
it's
up.
okay. It's okay. It's okay, sir.
All right. Okay, so let's have another illustration. Let me see. Let's solve this latest illustration on linear programming. I think that's the last one we have. Go to illustration number 4, Oshimiri. Go to illustration number 4. It's a compulsory question tested in November 2023. Okay, let's review the question together. Okay, yes, somebody should read. Who will help us to read?
Oshimiri Nigeria Limited, a company based in Aba, produces 2 grades of industrial varnish. The selling price and associated unit variable costs for the grade A and grade B are shown below. And we have a table showing particulars grade A and grade B. All figures are assumed to be correct. The fixed overhead cost of 2,600,000 per month. The fixed overhead costs are 2,600,000 per month. The company plans to maximize profits. The availability of resources for the following months is as follows. Materials 25,000 kg, skilled labor 48,000 hour, unskilled labor 39,000 hour, machine hour 50,000 hour. Required A. Identify the objective function and the constraint of the model to be used in determining the optimum production plan for the following month. B. Determine the optimum production plan for the month and associated profit. C. Explain the concept and significance of draw prices and stock variable in the context of the model used by the company in this scenario. D. Calculate the draw prices for the constraints identified in the scenario. And E. Suggest the way in which the identified model may be used to overcome capacity constraints during the following month and indicate the type of cost which may be incurred in overcoming each constraint.
Thank you very much, Kunle. That's the question. So the first one, examiner wants you to identify the objective function and the constraint of the model. Whether you are asked that a requirement or not is the most important thing you need to do. You have to formulate your linear programming model. Therefore, let me stop sharing this and let's solve the question within the next few minutes. So let me use this one. Stop sharing. Okay. Illustration 4. Oshimiri. It's a limited Nigeria Limited. Number A requirements. You have to formulate a linear programming model. Therefore, I would then say formulation of linear programming model. I told you there are 4 procedures you are going to carry out whenever you want to formulate a linear programming model. The first step is to define your variable. For me to define my variable, I would then say, in this question, the examiner has told me that there are 2 products, grade A and grade B. Therefore, because when I want to construct my graph, I can't be using grade A, grade B, all right, to label my graph. So I have to convert it to letter. I would then say, to define my variable, I would say let's grade A equal to A, grade B equal to B. So that's step 1. I've defined my variable. Step 2 says I should state all relevant constraints. Sorry, I should state the objective function. So I would then say objective function. I will go to the question. What's the objective that Oshimiri wants to achieve? Examiner has told us that to maximize contribution. Okay, the company wants to maximize contribution. So if that is the case, if examiner did not tell me that, I can see in this question, I can see selling price, I can see variable cost. By the time I minus variable cost from selling price, I will have my contribution, which means that the objective that this company wants to achieve is to maximize the contribution. So I would then say maximization of contribution equal to, I will need to go and calculate contribution per unit of each product for grade A and grade B. So that will take us to the next. How many pages do I need to estimate? Anyways, let's say this is the first page, second page, third page for my graph and solution table. Okay, let's use this. So workings. I want to determine working number 1, contribution per unit. Contribution per unit. And you know contribution is equal to selling price minus variable cost or fixed cost plus profit per unit. So grade A, then grade B. Selling price. The selling price of A is 2,100, then 15. 2,100, 15 for B. Then I will less variable cost. From the question, the first variable cost is material cost per unit. Material cost is 480,240 for A and B, 480,240. Material, direct material cost, 240, then 480. I also have skilled labor. Labor is divided into skilled and unskilled. For the skilled labor, 720 to 88. Skilled labor,
Hello, sir.
720. Yes.
The material cost for A is 480, while that of B is 240 instead of the other way around.
Oh, okay. Error of mind. 480. Yeah, you're correct. $480, then 240. Yes. Labor is 720 to 88. Then we also have unskilled labor, which is 120, 180. 180. Then we have variable cost. Sorry, we have variable overhead. 168,336. Variable overhead. 168,336. 168,336. So let me write this. So find me the difference. This represents contribution.
For A, it's 612. For A.
Okay. 612. Then 4, 7, 6. Please confirm.
456.
4, 5, 6. Okay. 4, 5, 6. So this represents the contribution per unit. So with this, I need to go and state my objective function. So here is 612 of A plus 456 of B. So I've stated the objective function. Step 2. Step 3 says state all relevant constraints. I will then say subject to, for the company to be able to achieve the objective of maximizing contribution, you must consider the following constraint. So subject to, I will then say the constraints. What are the constraints in the question? Examiner has told you that Material X is limited to 25,000 kilogram, skilled labor 48,000 hours, unskilled labor 39,000 hours, then machine hours 50,000 hours. Those are the constraints in the question. There are four different constraints. So I would then say material kilogram. We are told that it's limited to 25,000. Skilled labor hour. Unskilled labor hours. Then we have machine hour. We are told that variable overhead relates to machine hour. Then, of course, let's just go and determine material per kilogram. Remember what I told you when we're having optimal product mix. So the factors of production must be material kilogram, labor hour, or machine hour. So if you are given material cost, you are supposed to convert it to material kilogram. So working number 2 now. I want to determine material kilogram. So based on the previous formula that I gave to you, material kilogram is equal to material cost divided by material per unit. Material per unit. So for grade A, the material for grade A is 480 naira, and the material per unit is 240 naira. Therefore, for A, 480 naira divided by 240 equal to 2 kilogram. For B is 240 divided by 240 naira. That's 1 kilogram. Working number 3, labor hour. I want to determine labor hour per unit. And you know labor hour is calculated as labor cost per unit divided by labor rate. We have done this before. Therefore, for product A and B, for product A, labor cost, skilled labor cost is 720 and 288. So labor rate is 144 naira. Therefore, in fact, let me use a table to do this so that for product A, for A and B. So unskilled, sorry, first one is skilled. For skilled labor, labor cost is 720. Here is 720 divided by 144. What do you have?
5.
5.
That's 5 hours. Then for B, 288 naira divided by 144.
2.
That's 2 hours. Then for unskilled labor, labor cost is 120 naira divided by what's labor rate? 60 naira
60.
divided by 60 equal to 2 hours. Then for product B,
180.
180. So 180 divided by 60 equal to 3
3 hours.
hours. Okay, so that's that. Then for machine R, we also have machine R. We are told that machine R is on variable overhead, 84 naira per machine hour. So 168 divided by 84. Machine hour. So just say machine. So 168 divided by 84.
84.
Yes. Divided by 84,
2 hours.
which is 2 hours. And the last one,
336.
336 divided by 84, which
4.
is 4
4
hours.
hours.
Thank you. So with this, I've determined hour per unit and the material kilogram per unit. Okay. So that's that. So let's now go ahead and complete our formulation of linear programming. So for this, for material, we have 2 kg and then 1 kg of A and B. Okay. So I will then come here, 2 of A. Here is 2 of A plus, no, we have 1 kilogram for product B, for grade B. So just that one, just put B. There's no need for you to say 1B. Because we are maximizing contribution, you put less than equal to 25,000 kilogram. So I'm done with that. Move to the next one. For skilled labor, hour per unit of A is 5, then 2. 5, 2, 2, 3, 2, 4. 5, 2. 5 of A, 2 of B. Under scale. 5 of A plus 2 of B less than equal to the maximum labor hour for skilled labor
40
is
hours. 48,000 hours.
48,000. 48,000 hours. Then here is 2 of A plus 3 of B, I think, less than
Yes, sir.
equal to, is this
39,000
39,000?
hours.
39,000 hours. Thank you. Then for matching R,
2
we
of
have
A,
a
4
3
of
of
B.
4 of A.
No, 2
Did
of
you
A,
say
4 of B.
okay. 2A plus 4B less than equal to 50,000
50,000 hours.
hours. Finally, I need to state the non-negativity constraint. I would then say non-negativity constraints, which state that Negative output is not permitted. Therefore, product A and B must be greater than equal to 0. That is, whatever unit we are going to produce for A and B must be greater than or equal to 0. You cannot have negative output. The minimum you can produce is 0. And when you produce 0, it's as good that you did not produce anything. So that is for that. So with this, I will hang my 5 marks. I will pocket it. Move to the next one. So the B part, examiner wants us to determine optimal production mix that will maximize the contribution. So B1. So in this case, the next thing that we do, I've already formulated the linear programming model. So I can just say B. Let me just call this one B. Optimal or determining optimal product mix. So that's what examiner wants you to do in the B requirements. Determine the optimal production plan for the month and associated profits. So this should be more than 5 marks. So the first thing I will do is to formulate the linear programming model. But again, examiner has already asked us to do that. That's what we have done in A. Therefore, for me to do this now, we then say number 1, I will just bring out the equation and solve using elimination. So I'll just say elimination. Don't go and say elimination method. Just go ahead, solve your question. We have 4 different equations. So the first equation is 2A plus B equal to 25,000. That's equation 1. Then 5A plus 2B equal to 48,000. That's equation 2. Then 2A plus 3B equal to 39,000. Equation 3. Then the last equation is 2A plus 4B equal to 50,000. That's equation 4. So let's solve using elimination method. The first equation, which is 2A plus B equal to 25,000. So I will then say let A equal to 0. Therefore, B is equal to 25,000. If B is 25,000, okay, if B is 25,000, I can then say let me use a, let me just double, okay. Let me maximize the space. So I can say let B equal to 0. If B is equal to 0, then 2A will be equal to 25,000. Therefore, A will be equal to 25,000 divided by 2, which is equal to 12,500. I'm done with equation 1. In equation 2, we have 5A plus 2B equal to 48,000. 5A plus 2B equal to 48,000. That's equation 2. In this equation, we say let A equal to 0, then 2B will then be equal to 48,000. Therefore, B equal to 48,000 divided by 2, which is 24,000. Again, let B equal to 0. Therefore, 5A will be equal to 48,000. A equal to 48,000 divided by 5. What do you have there? 48,000 divided by 5.
9,600.
9,600. I'm done with equation 2. Equation 3 is 2a plus 3b, 39,000. 2a plus 3b equal to 39,000. That's equation 3. So let's A equal to 0. Therefore, 3b equal to 39,000. Therefore, b equal to 39,000 divided by 3, which is
13,000.
13,000. Then let's b equal to 0. 2a will be equal to 39,000. A equal to 39,000 divided by 2, which is
19,500.
19,500.
Okay. The last one, which is equation 2a plus 4b. 2a plus 4b equal to 50,000. That's equation 4. Therefore, let's A equal to 0, then 4b will be equal to 50,000. So b equal to 50,000 divided by 4, which is equal to 12,500. So let's b equal to 0. Therefore, 2a will be equal to 50,000. So a will be equal to 50,000 divided by 2, which is 25,000. So I'm done with step 2 now. Step 3 says we should construct a pivot table. Of course, this will be step 2 under the requirements. So number 2, 1, 2, 3, 4. Okay, let me manage it. So create a column for equations. No, before that, I'm sure this space will be okay. Oh, okay, let me just say pivot table. So in the pivot table, of course, create a column for A, another column for B. Then you have column for equations. So equation 1 is 2A plus B equal to 48,000.
25,000.
I tested you. Then equation 2. What's equation 2? That's 5A plus 2B. 5A plus 2B equal to 48,000. Equation 3, 2A plus 3B, is it 3B? Yes, 3B equal to 39,000. Then equation 4, 2A
2A plus
plus 4B equal to 50,000.
50,000.
So from our step 1, where we have eliminations, we said that when A is equal to 0, let me close this, divide this 2. So we said in equation 1, when A is equal to 0, B is equal to 25.
25,000.
B is equal to 25,000. And when B is 0, A is equal to
12,500.
12,500. In equation 2, when A is 0, B is
24,000.
24,000. Then when B is 0, A is
600.
9,600. Okay? A is 0 in equation 3. Then B is
13,000.
13,000. 13,000. Then B is 0. A is 19,500. The final equation, A is 0, B is 12,500.
Yes, sir.
B is 0, A is 25,000. Okay? The next step is to construct a graph. So, graph. On the day of your exam, whether you are given graph sheet or not, whenever you want to construct your graph, you have to make it very bold, make it bigger. Unlike the way you normally do in the class, whereby you'll be managing your note, cut one page into 4. I'll be writing in using tiny handwriting, tiny fonts. So you have to be careful. This graph go take the whole of your board. You're on your own. Latif, you're on your own. No, I don't know what you mean by that. In any case, so make it very bold and big, but not too big.
We'll plot 12,000 on this your small board. 12,000.
No worries. No worries. We are good.
You range it now.
Okay.
I'm going to range the figure.
Oh, yeah, range. Let's range and see.
You range it. You can't be using 1, 2, 3.
No
We go
worries.
just manage them.
Anyhow, we do not to just get answer, just do the right thing. Okay. That's how I'm going to draw I'm not using ruler, we manage it. So remember, one of the assumptions of linear programming is non-negativity constraints. You know, when you are drawing a graph, you have the positive side, you also have the negative side. But because of the fact that the assumption states that negative output is not permitted, so the minimum you can produce is 0. So this is 0.0 here. So I would then go to my pivot table. Now, let's say this is T axis. The horizontal, say this is K axis. Okay. Now, from my pivot table, for the first equation, I want to plot A against B for each of the equation. For equation 1, that is 2A plus B equal to 25,000. I will go to A. The highest value for A is 25,000. The lowest is 9,600. Highest value for B is 25,000. The lowest is 12,500. So first thing first, I need to scale my graph. Say, for example, this is 5,000, 10,000, okay, 15,000, 20,000, then 25,000. Okay. The same thing applies to k-axis. Get out. Okay, this is 5,000. 10,000. Okay, let me just.
Sir,
Yes, okay.
why are we using T and K axis instead of A and B axis?
Our letter is T and K now. Is it
No,
not?
sir, it's A and B. It's A and B.
Is it? And oh, I was still using. Thank you.
Yeah, you are
See?
using the previous
Kobo.
Yeah,
illustration,
yeah.
Toro and Kobo.
Can you see? Can you see? I'm still using. I'm still in the hold.
Is what?
Thank you. Yes, so it's
Don't
supposed to
worry,
be
when
A
you
and
get
B.
to we'll use your T and whatever.
Mm-hmm.
Yeah, your
So,
own.
Abi. Okay then. So, yes, this is 1, 15, 20,000, 25,000. Okay, so that's that. I've scaled my graph. So all I need to do now is to plot A against B. Okay, so I'll just go for the first equation. The value in the first equation for A is 12,500. So where I have A, this is A axis. I need to go and identify 12,500. 12,500 is in between 10,000 and 15,000. So let's say it's somewhere here. Okay, so let me change the color of my. So here is 12,500. Then B is 25,000. So here is the 12,500. What's wrong with you? Then here is 25,000. So you need to plot the two, you join the two together. You manage it. Anyhow I draw it, you manage it. So this is equation 2A plus B equal to 25,000. Okay, I'm done with the first one. I'll move to the second equation. Under the second equation, A is 9,600, B is 24,000. 9,600, let's say it's somewhere around this place.
Close to 10,000.
9,600. Then 24,000 is somewhere here.
Close to 25,000.
Yes, close to 25,000. Here is 24. Okay, so join the two. Okay. So that's equation 2A. Is it 2A? 5A. 5A plus
2B.
2B will be equal to
48,000.
48,000, right? In fact, this one too supposed to be straight like the other one. If I allow it, let me draw this one. 12,500. Correct. I'll show you. Okay. The next one, equation 3.
19.5.
19.5, then 13,000. 19.5 should be somewhere here.
Below 9,
19,
below 20,000.
500, 13,000. Let's say somewhere here. 13,000. So join the two.
Straight, sir.
Okay.
Wow, that's straight. Okay. Good.
Pardon?
That's good, sir.
Thank you. So write out the equation, which is
2a plus
equation.
3b. 2a plus 3b.
Okay, 2a plus 3b
equals to 39,000.
equal to 39,000. The last one, which is A is 25,000, B is 12,500. A is 25,000, A is 25,000. Okay. Then B is 12,500. 12,500 is in between, close to 13, just beside 13. It's where you have a 12,500. So let's say 12,500 is somewhere. Let me draw that one. Let me push this one up a little bit. No. Okay. Let me do this one too. Let me redo this one. Since the system is helping me. It's giving me a rejo. It's straightening the line. It's straightening the line for me. That's why it's good to use the right tools. Okay, so that's that. Oh, this 13,500. Okay. So we said the 13,000 should be somewhere here so that I can accommodate 12,500. Let me change the color to red.
The third equation as well.
It's okay. So here is, oh, it doesn't show now.
Yes.
Be careful. This is one of the challenges of online. And physical nursing àti lọ látàárọ̀. Yeah. Okay. 13. Let's say here is 13. So let me use red now. I would have used my marker and then move on to the next one. All this all this one is a long thing. So 13,500. Here is 13,000 rather. Okay. So I now join. I think it's 25 to 13. 25, 13. Is it?
19.5 to 13.
19, okay, 19.5 to 13. 19.5. Okay, yes, that's it. Here is 19.5 to 13. System, please help me. Make it straight. Wash it. So that's that. So
25,000.
that's it. 2A plus 3B. I think we are fine. So the last one, 25.
25,000 equals 12,500.
Okay, here is the 25,000. And then 12,500. Let's say 12,500 is somewhere here, for example. That's 12,500. Let me write 12,500 there.
Before 13.
Before the 13. So you join the two together. Hopefully.
Wow.
It's not me, it's the system that is helping me. I'm not using ruler, but Microsoft has already designed it. Okay. Microsoft has already designed it such that, see now, that small one, you cannot complete it. There is the 12.5. Let me redo it. Yeah, macro. Yes, so that's that. Write out the equation. This is equation
2A plus 4B
2A
to 50,000.
plus 4B equal to 50,000. So the next thing I need to do now is to identify the point of intersection between product A and B. We need to identify the point of intersection, all right? Therefore, because we are maximizing contribution, the point of your feasible region should be internal, okay? The feasible region should be internal. So the feasible region should be internal. So there's one point of intersection where you have 9,6. Let's say that is point X. There's another point of intersection here. Okay, let's say that is point Y. Then we also have the last one here, which is point C. Sorry,
Sir,
point X, Y.
Sir,
Yep.
Sir, can you please use another color to point those
I've already used another color, blue.
that black is not maybe another color that is legible enough.
So here is point C. So the first point is, second point is these are another points X and X, Y, Z. X, Y, Z. So we have 3 points of intersection based on our graph. Therefore, we need to find value of A and B at points X, Y, Z. Therefore, I would then say at point X, Y, Z for product A and B. So at X, the value of A is 9,600. At X, the value of A is 96. Value of B is 0. Trace it down.
0.
This is yes. 0. Then at point Y, we cannot determine the value of A and B because we have to use simultaneous equations since we are not having graph sheets. So we'll come back to this one later. Then at point Z, value of A equal to 0, B equal to 12,500. Okay. I would then say we need to get value for A and B at Y. I would then say to get the value of A and B at points Y. Identify the equations. Please, on the day of your exam, don't go and be writing all of this. Just identify the equation from the graph and begin to solve. Don't go and be writing all of this. Identify the equations that intersect at Y and solve simultaneously. Okay, so what do I mean by that? So at point Y, let's identify the equation together. Here is point Y. This is point Y. What are the
5A
equations
plus 2B.
So you will notice that there's particular equations. When you look at this line, this line where you have Z that went up to 12,500. What is that equation? That is equation 2A plus 4B. This is 1. Then there's another equation at this point where there's another equation of this 96 to 24,000. That's equation
5A plus
2A.
2B.
Sorry, that's equation 5A plus 2B. This equation is also, where am I drawing my? So this is one equation. This is another equation. These are the two equations that are intercepted at this point Y. The first one, this is point Y here. This is point Y where you see this arrow. That's point Y. At that point Y, this equation of 9,600 to 24,000, that's equation 5A plus 2B equal to 48,000. Then there's another equation at point Z that went up to 25,000. So that's equation 2A plus 4B.
Equals to 39,000.
So I would then say 5A at point Y, at point Y,
5A plus 2B.
5A plus 2B equal
Equals to
to
48,000.
48,000. Then 2A plus 4B, yeah,
E.
4B equal
Equals
to
to
50,000.
50,000.
So these are the two equations that are intercepted at point Y. We now need to solve using simultaneous equation. Let's continue from down there. See below. Let me use red. See below. Okay. So that's, we said equation 5A plus, we've already
2B
identified plus 2B
Close to
equal
equals
to
48,000.
48,000. Then 2A
3
plus
4
Plus
4B
4B equals to
equal to
50,000.
50,000. So we said this is equation 1, equation 2. So you multiply equation 1 with the first letter of equation 2. So 2 multiplied by 5A plus 2B equal to 48,000. Then you multiply equation 2 with the first letter of equation A. So 5 multiplied by 5A, sorry, 2A plus 4B equal to 50,000. So 10A plus 4B
4B
equal to 96,000.
96,000.
10A plus
Plus
20B
20B
equal to
250,000.
250,000. So this will cancel that. So 16B will be equal to 250 minus 96, 140 what?
154,000.
154,000. Therefore, B equal to 154,000 divided by 16, which is what?
9625. 9625.
Okay, 9625. 96. 96, okay, 9625. 9,625. Okay, I would then say substitute. for B in equation 1. Anywhere you see B, put 9625. So equation 1 is 5A plus 2 into 9625 is equal to 48,000. So 5A will be equal to 48,000 minus 9625 multiplied by 2. 19,250. Therefore, A will be equal to, what's the difference?
28,750.
8,750 divided by 5. So A is equal to what?
5,750.
5,750. So A is 5,750. B is 9,625. Okay, so let's go and put it in the table. 9625, 5,750. So where you have the question, on the day of the exam, don't go and be putting question mark because you want to determine value for that. If you do that, you're on your own. 5,750, 9,625. So when you, if you are using graph sheets, by the time you trace it to the right, to the left, what you are going to have is 5,750. If you trace it down, it will be 9,625 if you are using graph sheets. So that is that. Then the last one we are going to do, second to the last, is to determine the optimal, so determine solution, you construct a solution table. So for solution table, in the solution table, state your objective function. And the company wants to maximize contribution. The contribution of A is 612. 612 plus contribution of B, which is 456. So equal to total. So at point X, Y, Z. So at point X, we then say 612 multiplied by, what do we have under the graph? We have 96 of X, 0 of B. 96, 612 multiplied by 96. 9,600 plus 456 multiplied by 0. The second one, 612 multiplied by 5,750
750.
plus 456 multiplied by
9625. 9625.
9625. Then the last one, 612 multiplied by 0 plus 456 multiplied by, what do you have there? I think 96.
1250.
Pardon?
12,500.
12,500. So let's multiply. 612 multiplied by 96. That's 5,000,000.
875,200.
875 200. Then the second one, what do you have in the second one?
Seven nine two one six
79
21680.
2168. Okay. 216800, right? Confirm the numbers. Okay, 79. Okay, let me rewrite. 79.
21
Okay.
680.
680. Okay. So here is a 5700. So because we are maximizing contribution, we are expected to select the highest number. When you look at your total contribution, you notice that point Y has the highest number there. Let me circle it with red. So at this point Y, the highest total contribution is 7,921,680 naira, which is higher than the rest. That is the optimal level of activity. So this is the points we are going to make a decision. I would then say,
So that point Y is 7,908,000. The point Y, the total is 7,908,000.
yes,
Another person can confirm.
791
7,908,000.
7908.
like this.
Yes, sir.
Okay. So I can then say Oshimiri Nigeria Limited should produce 5,750 units of grade A and 9,625 units of grade B in order to maximize
That's our decision, sir.
contribution. Yes, in order to maximize contribution of 7,908,000. So optimal mix, just a repeat. Optimal production plan. We've already said it, but just to make it a point. So units, products, or say grade. Grade A, grade B. For grade A, we are producing 5,750. Nine, 6, 2, 5. That's 5 marks. Since the examiner is wicked, how could you give me 5 marks with all this stress?
Very wicked, sir.
That's disproportionate. Okay. Now, so far we have earned 10 marks. Number C, you are to explain the concept and significance of dual prices and slash variables in the context of the model used by the company in this scenario. Examiner wants you to explain the concept of shadow price and the significance of shadow price. That's what examiner is asking you to do. 4 marks. Just define what is shadow price. Shadow price is extra contribution derivable from the additional, all those stuff. explaining then what are the significance of shadow price. Then in number D, examiner wants you to calculate the dual prices for the constraint identified in this scenario. So what that means is that, let me just, okay, because I want to give you, I must introduce you to CVP tonight, so that in our next class, we just do calculation straight for CVP. Okay, let me do it this way. Let me stop sharing. Am I still sharing? Where did you go? Okay, stop sharing. Let me use this material to explain the other part. Which one is this? Okay. What's wrong with you now? Huh? Yeah. So let me use this material to explain to just show you the C, then I will then solve the D. Okay. Where are you? This is the question. Yeah. This is the question. Is it? No. I'm not sure. This is Fantino. Oshimiri. Not this one. This particular question has been tested twice by ICANN. So it has been tested twice. The last one was 2021.
Same question.
Yeah.
I'm actually mistaken. I don't do you know.
They can't repeat question 3 times
Mistake. I'm actually mistake.
in quick succession.
I'm actually mistake.
Okay, I hear you. Where is the question now? Wasting my time. I made a mistake. I should have used the name although I used different name here. So, okay, this is the question. Here it is called etc. So this is the question. Okay. So let me use the B. See, in my own, because I took my time, so I have 4 points of intersection here. Points X, Y, Z, then M. But in any case, our decision still remain the same. Okay. So our decision is at point Y. Right? So this is what I was trying to explain to you in the C parts. Examiner is asking you to explain the concept and significance of dual prices. Dual prices is the same thing as shadow price. So all you need to do is to define what shadow price is all about. We said shadow price is described as the extra contribution derivable from the additional units of limited scarce resources that have been fully utilized at the optimal level of activity. It represents the amount of a company. It represents the amount a company is willing and ready to pay for the use of an additional unit of a constraint. So, what are the significance of shadow price? The following are some of the uses of shadow price, including: one, it is used for determining the extra profit derivable from the additional units of a constraint. Two, it is suitable for determining transfer pricing. Then three, it can be used for determining the maximum amount that the company is willing to pay for its scarce resources or for its scarce resource. Then four, it can be used to determine the sensitivity margin of the scarce resource. These are some of the significance of shadow price. So examiner is now asking us, okay? Examiner is now asking us to determine the shadow price. And the examiner has given us 10 marks. You can imagine, 10 bonus marks. What are you supposed to do in this case? I want to understand. And I said I want to introduce you to CVP. Well, let's just complete this. Now we want to determine shadow price. I don't want to use this material to explain it. Let's solve it together. Stop sharing. Let's solve it together. Okay. This is what I'm sharing. This is what I need to share. Okay. So requirement D, calculating shadow price. Remember, when you want to calculate shadow price, you are expected to, the first step is to identify the equations that intercept at the optimal level of activity. Our optimal level of activity is at point where we made the decision. That's our optimal level of activity. So at that point, what is the value of, what are the equations that intercepted at the point Y? So the same equation, that's equation 5A plus 2B. Okay, equation 5A plus 2B, 48,000 plus, and then equation 2A plus 4B equal to 50,000. That's the equation at point Y. That's the equation at point Y. Therefore, that's it. That's the point Y. So, to calculate shadow price using dual method, first thing first, you identify the equation that intercepts at the optimal level of activity. Therefore, let's say at point Y, 5A plus 2B equal to 48,000. Then 2A plus 4B equal to 50,000. Then I've identified the equation. Step 2 says find the dual problem. Okay, I will then say dual problem. So to get the dual problem, first thing first, I need to indicate the original problem, which is 5A plus 2B equal to 48,000. 2A plus 4B equal to 50,000. Then the contribution of A is 612 plus contribution of B 456. This is original problem. Okay, so to get the dual, change row to column. So the first row is 5, then 2, then 48,000. Second row, 2, we want to change the second row to column. 2, then 4, 50,000. The third row, 6, 1, 2, then 4, 5, 6. The letter in the original problem is A and B. You can change it to X and Y. X plus Y plus Y, X plus Y. Let me push this one to the front. Okay, so this represents the dual. Then step 3, solve the dual simultaneously. Therefore, simultaneous equation. So I will say 5x plus 2y equal to 612, equation 1. 2x plus 4y equal to 456, equation 2. So 2 multiplied by 5x plus 2y equal to 612. 5 multiplied by 2x plus 4y equal to 456. So 10x plus 4y equal to 612 multiplied by 2. That's 1,000.
1,224.
224. Then 10x plus 20y. 456 multiplied by 5.
2280.
2,280.
2,280. So this will cancel that. So I have 16y. 2280 minus 1224.
1,056.
1,056. Therefore, y is equal to 1,056 divided by 16. What do you have?
66.
66 is y. Okay? Then substitute. For y in equation 1. So equation 1 is 5x plus, I think 2. Is it 2? Yes. 5x plus 2 into 66 equal to 612. So 5x equal to 66 multiplied by 2 612 minus 132.
132.
Okay. So 5x. What's the difference?
480.
480. Therefore, x equal to 480 divided by 5. What do you have?
96.
96. Therefore, shadow price would then be, of course, figures will be in Naira. X equal to 96, Y equal to 66. That's the extra contribution derivable from the additional units of the limited scarce resources that have been fully utilized at the optimal level of activity. This is how to calculate shadow price. This is how to calculate shadow price. Then in the requirement number E, you have to suggest the ways in which the identified model may be used to overcome capacity constraint. That's very straightforward. But in any case, let me stop sharing this and move to the, it's almost time. So we can't do CVP today. So let me just use this material to explain some things. Okay. Okay, yeah. So let me use this material to explain the number E. Okay, this is the shadow price. Well, we have different okay. I'm trying to get okay. Is it 3? 5x plus 2y 612. That's at point. I want to check the equation. Is it the same? 5x plus 2. Let me check. Our own is a 2x plus 4y at equation y. 5x plus 2y. Yeah. So let me explain the number D. What examiner, number E, what examiner is actually asking you to do in this E is that, you need to personalize this. Examiner is the same thing we did under, was it under acceptance or rejection of a special order? You remember the question on the Kike Lomo when you have to determine the input material, that you list the input material constraint and all of that. The same thing is the same thing you want to do here. Examiner is asking you that you should suggest the way in which the model can be used to overcome capacity constraint. What are the constraints? The maximum capacity the company has for material kilogram is 25,000. Labor hour, scale labor hour is 48. On scale is 39. The machine hour is limited to 50,000 kilograms, 50,000 hours. So examiner is now asking you to suggest the way of overcoming the constraints. What are the likely constraints you can have under material? Okay. Number one constraint is insufficient funds. Okay. If you don't have sufficient funds, what do you do? How do you overcome it? Of course, you have to borrow money to go and buy the sufficient material needed. Then what are the associated costs that are going to the company will incur? One of them is interest expense, because the loan that the company will borrow to to buy the material. It's not for free. It's not for free, so that will be cost associated with the loan. So that's what I explained in this first one. The company can borrow loan to buy additional material X kilogram needed to maximize contribution towards profit, though this may result in the interest expense being incurred on the loan. Then number two, the company can outsource production capacity to a reliable supplier. However, this may increase production costs or lower quality of the industrial varnish grades, loss of proprietary technology, and impair the reputation of the company, especially if the supplier cannot deliver according to specification. You must be able to think outside the box. That's the point. You must be able to think outside the box. Then number three, skilled labor can work overtime. Okay, because they are skilled labor is usually at full capacity. So because they are operating at full capacity, they may likely work overtime for the company to be able to achieve its aim. Therefore, I now said here that skilled labor can work overtime to meet the required labor hours. Okay, but extra labor costs will be incurred to compensate for the extra hours worked. Okay, so that's that. Point number 4 that I stated here is that the company can also hire additional labor to meet the required labor capacity. This will mean additional labor costs will be incurred. Okay, this will mean additional labor will be incurred because if the skilled labor are already working at full capacity, so and then of course the company may likely need to employ additional labor that will do the work. Then number 5, the capacity of the machine can be increased. You know, we have machine hour. They said machine hour is limited to 50,000. It's limited to 50,000. So in order to overcome the constraint on machine hour, the capacity of the machine can be increased to enable shift work. Okay, this may increase productivity, but may result in additional overtime costs being incurred and may lead to machine breakdown due to excessive usage. So if the machine breakdown, the company will also need to repair it. That's an additional cost. Then the last point I made here is that a new machinery that can produce better and high quality products with increased operating efficiency should be purchased. So if there's a new technology or there's a new innovation in the market, so it's better for the company to purchase the new machinery, which has the capacity to produce better and high quality products. This will enhance operating efficiency. So, of course, if the company decides to buy the new machine, it will increase productivity, but will result in a significant investment in non-current assets. So another thing is that the company may need to know whether they want to know whether they have the funds. The company will need to determine whether the fund is available to purchase the new machine, or they also go ahead and borrow the money to purchase the new machinery. So these are the points are listed to address the number E requirement. And according to your question, the number E requirement is just 6 marks, 6 bonus marks. You pocket it. My highest network is glitching. Your high is scared. You're on your own. All right. So, yes, that is the question. That's the question. That's end of with this. That's end of linear programming. Like I told you last week, when you have a question on linear programming, please don't make it your first attempt, especially when you have shadow price. It will take time. It's very straightforward, but it will take time to solve. Therefore, don't make it your first attempt so that you don't waste time. Go for cheaper ones. Go for cheaper ones, then you come back to your linear programming later. No matter how simple is your linear program, it will take time to solve. All right. So that's it. So let me know if you have any question for me so that we can close the class.
Even if the linear programming is a compulsory number 1.
That's what I'm saying. That's what I just said. Irrespective whether it's compulsory or is in section B or C, just keep it, hold it first. Go and look for cheaper ones, the one you can solve within 30 minutes. Pocket like 3 You can solve within 30 minutes. Then you can take your time on the compulsory. If linear programming is the compulsory one, take your time on it. All right? Because if you make it your first attempt, you think you are solving well. You are enjoying it the way you are solving it, you are enjoying it, but you wouldn't know time is going. Before you know it, 1 hour, 1.5 hours, you are still doing it, but you won't know. You won't know until the invigilator tell you that, okay, 30 minutes more. Meanwhile, you are still on number one question. So I don't know how the magic we are going to do in 30 minutes to solve 4 additional illustrations. So please don't make it your first attempt. Okay, guys. Yes, in the absence of no question, I know some of you have disappeared already. Thank you for all of you that wait behind. And next, Armand, where have you been today?
I've been around, sir. I've been
All of
here.
you, apart from Abdul Latif and Kunle, and then one other voice that I heard, every one of you have been so quiet tonight, as if you are tired, you struggle to attend the class, you know. But in any case,
No,
Victoria.
I've been taking my notes, sir.
but I couldn't hear your voice.
Now we are here paying attention.
I saluted
You are
when you came.
Yeah, I'm only trying to
Try.
comprehend the whole solution and everything.
It's all right. No worries. Amarachi, are you there too?
Yes, sir, I'm here. Good evening.
Good evening. Evelyn, are you still there, or you just on your open your screen and then waiting for the class to stop? Some of you might have slept off, but in any case, all right. Thank you guys for your time and then patience.
Welcome.
We'll continue
Thank you very
next
much.
week by the grace of God. Good night to everyone.
Sir.
Likewise.
Sir.
Good
Good
night.
night, sir.